Good day, viewers. Welcome to another edition of Subject Math. Today we're talking about what? Inequalities. So in these inequalities, we'll be going straight ahead to what we call the number line notation. Number line what? Notation. Now when I talk about number line has to do with operations in a line. For example, this here is your number line. This is an example of what you call the number line. We'll have the middle here to be 0. We'll have here to be what? The negative. Minus 1, minus 2, minus 3, minus 4, minus 5. We'll have here to be the positive, which is what? 1, 2, 3, 4, and 5. Now having this here, so if you want to carry out operations here, we can say, let's say we want to carry out what? 3 minus 4 plus what? 8. 3 minus 4 plus 8. Now, this is your 3. It says minus 4. 1, 2, 3, 4. This is your minus 4. Let's extend this a little bit. 5, 6, 7, 8. Now, it says what? Then what? Plus what? 4. Then plus what? 4. This becomes plus 4, plus 8 rather. So 3 minus 4 gives us minus 1. It then says what? Plus what? 8. Plus what? 8. So this is because you count 8. 1, 2, 3, 4, 5, 6, 7, 8. That is equal to what? 7. So this guy here is equal to what? 7. Now this is simply what they call, or this is what is known as your what? Your number line what? Notation. Now, when we carry out so many operations on the number line, which are going to include the following. Now, we go moving forward. So this tells us about, it says here that what? All operations can be carried out in the number line system, and we have our sign notation. So we have the sign notation here, which this sign, how do we make this sign? We make this sign using our right hand. Watch my elbow. Right hand here is your greater than. So this sign here is greater than. Are you with me? Why this? My left hand is what? Less than. So you can use this what? As a guide. Your right hand is your greater than. Your left hand is your what? Your less than. So this is your greater than. Why what? Your greater than with something under, with a dash under, is what? Greater than or equal to. We have the less than here, which is your left arm, and left arm with something under here is what? Greater than, less than, or what? Equal to. Now we'll move ahead to what they call strict inequalities. When I talk about strict inequalities, what are we talking about? The less than and greater than are called strict inequality. When I say strict inequality, let me try to explain here. I have what? An example. If I say that x is greater than what? 5. X is greater than 5 simply means that x is any number from 6 straight down to infinity. As far as that number is greater than 5, so 6, 7, 8, 9, 10, till what? Positive infinity is a number defined as s is greater than 5. But why is it strict? It is strict because if I say x is greater than 5, it simply means that x can never be 5. X can never be 5 or any number less than 5. So that is why it is known as what? Strict inequality. But if I say what? X is what? Less than 5. If x is less than 5, this means what? S is any number that falls between 4, 3, 2, dash to negative what? Infinity. So this is what? S is greater than what? When I try to explain, I'm going to be explaining the weak inequality. You're going to understand what this try actually means what? Better. So what? Greater than and less than are strict inequality. Please, I would like you to what? Note that because it's very necessary. So moving ahead here, we have what? The weak inequalities. the weak what? Inequality. So greater than or equal to. This sign here, you're greater than or equal to and less than or equal to are known as what? Weak. They are known as what? Weak inequality. Are you with me? So your less than or equal to is also known as what? At most. And greater than or equal to is known as what? At least. If I say K is at least 6, or K is less than or equal to, so it's greater than or equal to 6. What am I trying to say? That K is any number from what? 6, 7, 8, 9 to positive what? Infinity. But if I say K is what? Less than or equal to 6. Less than or equal to 6 here simply means what? Now my K is from what? From 6, 5, 4, 3, 2, 1, 0, minus 1 to what? Negative what? Infinity. Now look at, both of them have what? 6 in common. That is why both of them are called what? Weak. Weak what? Inequality. So let us try to speak questions and attempt them to see what inequality really is. Now, we have here linear equation in one variable. Okay, now look at this. 5x minus 4 is greater than what? 21. Collecting like terms, this becomes that 5x here is greater than what? 21 plus 4, as 5x here greater than what? 25. Dividing both sides by 5. So x here is equal to 25 divided by 5. We give us what? The value. Give us the value what? S is greater than what? 5. Now, this inequality, it just follows the same pattern of equation. Just that here, we are using the what? The inequality signs instead of the usual equal to. So there's nothing, and sincerely nothing to be afraid of. Here, 2x minus 3 is what? Less than x plus 7. So we have to use the principle of collecting the like terms. So this is the principle of collecting like terms. So this becomes 2x. This guy comes over here, it becomes what? Minus x less than 7. If this guy comes here, it becomes what? Plus 3. So this guy minus it, that's what? X here is less than what? 10. So with this, that's what the answer to this what particular equation. So here, I'd like us to pay close attention to this question. So here, this is what? Y. This guy comes over. Okay, y plus 9 is what? Less than or equal to what? 5y minus 7. So y here minus 5, well, that's collecting like that. It's less than or equal to minus 7 minus 9. So with this is now what? Minus 4y. Minus 4y, is less than or equal to minus 7 minus 9. That is minus what? 16. So with this development, I'm dividing both sides by minus what? 4 by minus 4. But in inequality, whenever you divide by the negative coefficient, it reverses this particular sign. Whenever you do what? Divide by negative coefficients, it what? It reverses the inequality sign. It reverses the what? The inequality sign. So with this development here, this becomes that what? Y here is now what? Y is what? Greater than or equal to what? 16 over 4. So y here is greater than or equal to 16 divided by 4 gives us a positive value what? 4. Now, let us pay close attention because this particular reversing of sign is where there is a bit what? Technical in solving this kind of what? Question. Okay, the solution set of the inequality. Here, this becomes the solution. Expanding this, x times x squared, x times minus that's minus x here is less than, expanding this, that's x plus 1, x plus 1. So x squared minus x is less than equal to x times x, that's what, x squared, plus what, x plus x plus 1. So this becomes that x squared minus x is less than x squared plus 2x plus 1. So at this junction, collecting like terms. So collecting like terms here, this becomes that x squared, okay, x squared minus x squared minus 2x is equal, okay, it's less than 1. So this becomes what? That this thing this cancels this. This is now what? Minus 3x is less than what? 1. Divide both sides by minus 3. Now this what happened to your side? Your side has to what? Change. This becomes x is now less than what? Minus 1 over 3. So this is what? Your final answer to this particular equation. Now, if x is a positive real number, find the range of the values for which 1 over 3x plus 1 over 2 is greater than or equal to 1 over 4x. First and foremost, find what? Find the LCM of 3x, 2, and 4x. So the LCM is what? 12. So multiply through by 12x, which is your LCM. So 12x, open bracket, 1 over 3x, plus 12x, open bracket, 1 over 2, 12x, open bracket, 1 over 4x, such that x cancel x, 3 here 1, 3 here 4. 4 times 1, 4, plus 2 here 1, 2 here 6x, 6x times 1, that is 6x, is greater than or equal to x cancel x, 4 here 1, 4 here 3, 3 times 1, 3. At this junction, this now becomes that 4 plus what 6x is greater than or equal to 3. As you collect your like terms, this is 6x is greater than or equal to 3 minus 4. So 6x is greater than or equal to what? Minus 1. So your x here is greater than or equal to minus 1 divided by 6. So this is your final answer. If you want to use this particular approach, you can what? Say that since you have 1 over 3x plus 1 over 2 greater than or equal to 1 over 4x, you do for your LCM here. Your LCM here is what? 6x. 6x divided by 3x, that's 2. 2 times 1, 2 plus 6x divided by 2, that's 3x. 3x times 1, 3x is what? Greater than or equal to 1 over 4x. You can cross multiply here. Cross multiplying, what are you going to have? Okay, you are going to have what? Now what? 4x open bracket 2 plus what? 3x is greater than or equal to what? 6x. So expanding this is now what? 8x plus, okay. Let's see to this. Okay, at this junction, you can say what? Divide both sides by what? X. Such that x cancel x, this cancel this. So what are left? You are left what? 4 open bracket, what? Rather, 4 times 2, 8. 4 times this, that's what? Plus what? 12x is equal to what? 6 what? X. So at this junction, your own then will collect like terms. So please, going back to this, please don't forget we cancel what? We said let x cancel this, so we're no longer having what? X here. So with this development, this is now what? 12x is equal to what? 6 minus what? 8. So 12x is what? Greater than or equal to 6 times 8, that's give us what? Minus 2. So what? X here is what? Greater than or equal to minus 2 divided by what? 12. So x is greater than or equal to what? 1 minus 1 over 6. That's the same thing we got what here. So whichever way that you deem fit, you can solve this particular problem using that particular what? Pattern. Okay, now here we go ahead to what? Graphical representation of inequalities. Now we have what that here x is greater than or equal to 4. Now for greater than or equal to 4, this is the number line. Let us look for 4. Positive 4 is here. When is greater than or equal to, then the point here will be shaded. Greater than or equal to. Greater than or equal to what? So if we shade this point, so all values what? Above. This is what? X is greater than or equal to what? 4. But this x is less than what? Minus 4. If x is less than minus 4, that means what? This is the point here, and x is what? Less than minus 4. And he says that what? Minus 2 is less than x, and x is less than what? 3. Therefore, instead of minus 2, which is what? This point here is minus 2, and what? Plus what? Plus 3. So your x is within the range of minus 2 and plus 3. Now look at this fourth guy. He said 5 is what? Less than or equal to x is less than or equal to 1. 5 and what? 1. This is your 1. This is your what? Your 5. They say 5 is less than or equal to. So this becomes shaded, and this is what? Open. So your value is from this to this place. So these open ones are strict inequality. The open ones are strict inequality. Why the what? The shaded ones are what? Your weak inequality. So I'd like us to pay close attention to it. So this is how you present what graphically. So I'm going to start answering questions and representing the answers to these questions in a graph manner. Now, this question said find the solution set of the what inequality. And what is the inequality? The inequality says what? 3x plus 2 is less than or equal to x plus 4. What's your solution set? The solution set here says, okay, collect like terms less than or equal to 4 minus 2. So this is collecting like terms. So this guy, that's what? 2x is less than or equal to what? 4 minus 2, 2. So dividing both sides by 2, sorry, there are 2 cancel 2. So x is less than or equal to what? 1. So this question said what? Represent your answer graphically. So represent your answer graphically, we have what? The number line. We have what? 0, 1, 2, 3. We have here minus 1, minus 2, minus 3, minus 4, minus 5. So with this development, they say what? X is what? Less than or equal to 1. So if S is less than or equal, this is a 1. Since it is less than or equal to, this has to be what? Shaded. To telling us what? That it is less than or equal to. So it's less than or equal to 1. So that means your S takes this value. S takes this value. What is the set of value? 1, 0. Or rather, you can write that what? S is such that what? S is such that S takes what? 1, 0, minus 1, minus 2, minus 3 to what? Minus infinity. So this is your what? This is your set of solutions for the particular what? Inequality. Okay, having this here, so your y raised to power 2 minus 3y, if this guy comes over, that's minus 18, is greater than 0. So this say here becomes what? Y square, using your what? Factorization, this multiplied by this, that will give us minus 18y squared. So how do we break this minus 18y squared to give us this? Now 6 times 3 is what? 6 times 3 is 18. So we can say what? Minus 6y plus 3y minus 18 is greater than 0. So this becomes what? Y open bracket. What? Factorizing this, we are left with what? Y minus 6. What's common here? Plus 3 is common. Bring it out. If I bring out plus 3 from here, I'll left with y. If I bring out plus 3 from here, I'll left with minus 6 is greater than what? 0. So with this, so we say y plus 3 open bracket y minus what? 6 is greater than 0. So y plus 3 is greater than 0, or y minus 6 is greater than 0. So y is greater than what? Minus 3, or y is greater than plus 6. So this is your answer to this particular what? Quadratic expression. So going further here, we have this question here, an inequality, that what? 2 minus x is greater than what? X squared. So x squared here plus what? X minus 2 is greater than 0. Collecting like terms, rather, I moved all this to this side, making it equal to 0. So with this, okay, so with this then becomes x squared factorizing, or getting the factors. X plus 2x minus x minus 2 is greater than 0. So with this, I can now factorize. Since x is common, bringing out your x from here, I will have what? X plus what? 2. Bringing out minus 1 from here, I will have what? X plus what? 2 is greater than what? 0. So what? X minus 1 here, x plus 2 here is greater than 0. So x minus 1 is greater than 0, or x plus 2 is greater than 0. So x here is what? 1, or x here is greater than what? Minus 2. Now let's look at our option. Obviously not A, so A is out of it. Not B, not C. But now let's look at D. D was arranged in this manner. So now minus 2 is less than x is less than what? 1. Okay, I can now arrange this guy. So they say what? If you have that what? If x is greater than what? Minus 2. Therefore, minus 2 is less than x. Where x is what? Less than 1. So this is what? Your final answer, which is what? D. Okay, determine the set of solution of the inequality, hence represent in a number line. So have we that x squared minus x minus 10 is less than 2, as x squared minus x minus 10 minus 2 is less than 0. So x squared minus x minus 12 is less than 0. 2 factors of 12, that's 2 factors of 12, 1 was 12, 2 here 6, 2 here 3, 3 here 1. So we'll have that what? X squared minus 4x plus 3x minus 12 is less than what? 0. So with this development, we now have that what? X is common, factorize, so x minus 4 plus 3 is common, that's what? X minus 4 is less than 0. So x plus 3, x minus 4 is less than what? 0. So x plus 3 is less than 0, or x minus 4 is less than 0. So x here is what? S is less than what? Minus 3, or S is less than what? Less than 4. So with this, I can represent this in the format that what? Minus 3 is less than S is less than 4. And this question said what? Represent in a number line. Represent a number line, you draw your number line. So since this is a number line, you have here your 0, here minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5. So they say what? The x is less than what? Minus 3. This is your minus 3 here. Let me use another marker. This is your what? Your minus 3 here, and this is your plus 4 here. So your s is from this range to this range. If you don't represent a normal line like this, you can represent a normal line in another format, which is, or let's represent another format. We have our number line system here. We call this point here 0. Call here minus 1, minus 2, minus 3, minus 4. We have here 1, 2, 3, 4, 5. Please bear with us. This is not a standard graph. So since we have a number line here, we now have here that to be what? Minus 3. For minus 3, this is for minus 3 here. To what? To 4. This is 4 here. So this will meet at this distance. Can have please make sure it doesn't leave this line. No, it doesn't leave this line. So we'll have this, and we'll also have this. So any of these two representation is what? Correct. Both of them says that minus 3 is less than x, which is less than 4. So if log what x raised to power 2 base 10 is less than or equal to, if log what x raised to power 2 base 10 is greater than or equal to 2 plus log y base 10. We are asked to express y, that is, make y set a formula. So this becomes what? That log x raised to power 2 base 10 is greater than or equal to what? This is what? 2 log 10 base 10 plus log y raised to power 10. You have to watch the video on log to understand why this happened. So this is now what? Log x raised to power 2 base 10 plus greater than or equal to log 10 raised to power 2 base 10 plus what? Log y base 10. So with this comes over here to be log x raised to power 2 base 10 minus log 100 base 10 is greater than or equal to log y base 10. So with this development, the minus here becomes what? That log x raised to power 2 base 10, okay, because of your minus, and this is log 10, this is what? X raised to power 2 divided by 100 is greater than or equal to log what? Y base 10, where this cancels this. So x raised to power 2 over 100 is greater than or equal to y. So with this development, where is our answer? Okay. So we have that y here equal to what? X raised to power 2 over 100. So with this, the answer to this question here is what? C. Option what? C. So it's very easy. That's like you just need to understand the laws in this sort. So this inequality is just like your normal equation, just that what it is having the signs of equality, which are greater than, less than, greater than or equal to, less than or equal to. So with this, it takes us directly to what we call absolute value. So if a number is x, if a number x is positive, the absolute value of x denoted by, this is your absolute value. If you don't call it absolute value, you can call it what? You can also call it the modulus. It's sometimes called modulus. When you get to higher institution, you get to use it under complex numbers and all. You get to call it what? Your modulus. But at this level, we refer to it as what? The absolute what value. So if I have 3 here, what's the absolute of 3? 3. If I ask minus 3, what's the absolute of minus 3? That is what? 3. So you get the absolute of any value, it gives you the magnitude of any value, what? Irrespective of the sign. So The absolute value of a given number gives the magnitude of the number irrespective of the sign, whether negative or anything. It gives you what that what particular number. So it denotes the distance between 2 points. In a Cartesian plane or in a plane, it denotes the distance between 2 points. Now let's just take a question to back this up. So before I proceed, your absolute has what 2 sides. It has the positive side and it has the negative side. So the positive side is such that what your x is greater than 0, while the negative side is such that your x is what less than 0. Now look at this question. Find what the absolute. That's what absolute of what 2x minus 3 is not less than what less than 4. Now, so that to take off this absolute, we are going to have a positive side and a negative side. So this is minus 4 is less than what 2x minus 3 is less than what 4. This happened this minus 4 came because of the presence of what your absolute, because your absolute has what 2 sides. So with this now become minus 4 plus 3 is less than what is less than 2x less than what 4 plus 3. So with this minus this plus this, that's going to give us what minus 1 less than 2x is less than what 7. So you divide what all side by what 2. So this is now what minus 1 over 2 is less than x is less than what 7 over 2. So this here is the set of solution to that particular question, which says what 2x minus 3 absolute less than 4. Okay, so here we are having 3 p's. Now these p's are given without answers. So you have to attempt them and provide their solution. So you have your full options. So please try as much as you can to solve them, because you shouldn't forget that practice makes perfection.